this session. Yeah, and I'll make the recording available tomorrow. Thanks for joining. If there are any questions while I'm going through the session, please just either text or unmute and ask away. So just some, I guess, some notifications that I need to let you know is that you should complete your ICE tasks by the 18th. Okay, so please don't wait till the 18th. Please complete them before that, because that is the deadline. There's 4 ICE tasks. I think it covers up to learning units 3 or 4 at most, so you should be well prepared to cover that, especially if you're finished with assignment 2 by now. So please complete that. Okay, that's ICE tasks. And then secondly, I've made some practice tests available for you. So please check the more resources and the practice test folder and give those tests a go. Okay, those marks don't count for anything, but it does help you prepare for the exam because they are timed. All right, so I encourage you to work through that. All right, so for today, I'm going to go over the second last learning unit. Yes, we only have 2 more learning units, and by next week we should have gone over all of them. All right, so we have completed the syllabus. All right, so today we're going to go over hypothesis testing, and as usual, to explain that, I'm going to do it by an example. I'm going to share my screen. Just give me a second. Please let me know once you see my whiteboard. Basically, the text is saying the manager of a large shopping mall in Neisner. If one of you can just give me a heads up that you can see it, that would be great. Can you see the whiteboard? Great, thanks, Caroline. Okay, so let's get back to it. All right. So hypothesis testing, basically hypothesis means a theory or belief or a claim. And hypothesis testing means you're going to test that claim to see if it's true, right? And we do it statistically. And what I mean by statistically is that we use numbers from a sample to decide whether something is true about the population, right? Or in other words, the claim. So you may have become familiar with this this drawing of explaining a population and a sample. So the population is the entire group that you're interested in, and that's often not feasible to consider every single person in the population, right? It's just not financially viable or practical for various reasons. So what we do is we take a sample, all right, and we try and draw conclusions about the bigger picture. Now, hypothesis testing says basically we claim that the average of this population, this outer circle here, could be something, right? And we could be measuring anything. Now, in this example, what we're claiming is that the shoppers of this mall in Neisner, right, they spend on average, let me change the color, maybe it might be better. If you can't see, please let me know. So the claim is that the population, right, that every shopper on average spends about 85 minutes. So every shopper in this population. But as I said, it's not feasible to get every single shopper. So what we do is we take the sample. We take a smaller sample, right? And in this example, we're actually only taking 132. That's the sample size. So we take 132 of them, and we can get the average of the sample. This is feasible because we only have 132 people, and we've done that, right? If you look at the problem, it says the average of them is 80.5 minutes. Okay, so the average of the sample, right here, which is x bar, I'm just going to draw a line here. Right, the average of that sample x bar is 80.5. All right, yeah, minutes. That's what we found to be their average shopping time. Now, for the population, what they claim or what they believe is that the average, the true average, is 85 minutes. So we believe mu, which is the population average, to be 85 minutes. All right, and basically what you're going to test is you're going to use this sample, all right, and all the information you can get from the sample to test whether this is true. That's what hypothesis testing is, essentially. All right. Now, for the first question, A, it says formulate the null and alternative hypothesis. Now, what the null and alternative hypothesis is, basically, it's the null hypothesis mathematically we represented by H naught. Right, that's your null hypothesis, H naught, and then the alternative hypothesis we represented by H1. All right. Now, basically what the H naught and H1 is one will have, you can think of them as complementary events. What I meant by complementary events, remember from probability, if it rains, then the complement of that is it doesn't rain. Or if you flip a coin, if you get a heads, then the complement of that is tails. It's the total opposite. That's what a complement is. So that's what your H naught and H1 basically is. They're complementary events. So H naught is if we believe three things, right? It could be three things. H naught can take on the values of equals to, you can take on the value of less than equal to, and you can take on the value of greater than equal to. These are the three possibilities that H naught can take on. Now, how do we know which one to use? Well, we have to read the text for the question. We have to look at what they're claiming. And if you read the first two lines, it says that the manager believes that visitors of the mall spend on average. So he doesn't say anything, or she doesn't say anything about spending less than or more than 85. They believe they spend 85 minutes. So that's equals to. That means that they believe the average mu, the true average, is 85. And so this is H naught, and as I said, H1 is the complementary or the opposite of H naught. So that'll be mu not equal to 85 minutes. Right, and that's basically how you state your hypothesis. Right, in this example, this is how you state it. Okay, remember H naught can take on any of these three values, which means H1 can take on any of these three values. These are the opposites. All right, and in this case, we're dealing with this option. All right, I'm just going to pause there for a second and check if there's any questions, or are we good so far? I'm going to go back to the chat. No questions, so I'm assuming everyone's following. All good? All right. Okay, let's continue. So that's question A, right? That's basically how you state your hypothesis. Okay. Now, step 2, or question B. So we've answered question A. Now let's get to question B. Question B says, which test statistic, Z or T, is appropriate for this test and why? Okay, this is what I need you to remember for hypothesis testing, right? You can have two types of tests when you're dealing with averages, and that's what we're working with right now. We're working with mu, right? So that's an average. When you're dealing with averages, it can either be a Z statistic or it can be a T statistic. And how you know which one to use is you use this rule here. If your sample size, that is, if your n, right, is greater than 30, then you use Z. If the sample size is not greater than 30 or less than equal to 30, then use the t statistic. So basically the opposite of this, right? So this is your one guiding rule to use the Z stat. So if your n is less than equal to 30, less than equal to 30, use the t statistic. The only time this is overridden, so say your n is smaller than 30, say your n is 15, right? It is smaller than 30. The only time you would use a z-stat even though the sample size is less than 30 is if the question explicitly tells you that the sample is drawn from a normal distribution. So if they tell you it's drawn from a normal distribution, then you use the z-stat irrespective of what the sample size is. Okay, so make sure you remember that. Okay, so just follow that rule. Okay, the reasoning behind this is it's beyond the scope of this course, but you just need to remember that. This is how you identify when to use the Z or the T stat. Whenever it's an average like mu, then you have to decide whether to use the Z or the T stat, and you use the sample size to guide you. All right, so that's question B. Question B, we are going to use the Z stat because our sample size is well above 30. There's our sample size here, it's 132. So it's bigger than 30, hence we're going to use the Z statistic. All right, let me make some space on the board. Okay. All right, let's get back to it. So we're going to use the Z stat. I'm just going to underline it so we know that. All right, so that's question B. Now, question C is going to involve a lot of steps, and if this was an exam, this is where the bulk of the marks are going to be for this question. All right, so it's a process. You've got to complete about 3 or 4 steps to finish it. So I'm going to take you through each of those steps. If there's any of them that you're not sure of or you need me to go back and explain, please let me know. It's very important you understand this, okay? Because this type of question can easily carry at least 10 marks. All right, so it's quite a lot of marks. All right, so let's go to question C, which says conduct a hypothesis test for a single mean at a 5% level of significance. I'm going to underline this because that is going to be important. We're going to use this number, 5% level significance, right? To support or refute the manager's belief. What management conclusion can you draw from these findings? Now remember, the whole idea of this was to use the sample to test whether the claim of that the manager is making is true. A little handy, I guess, advice I can give you is when you declare your hypothesis in your first step, that is when you have your H0 and your H1, it's a good practice to write where the claim belongs, right? So for instance, if you look at the question, it says the manager believes that shoppers spend on average 85 minutes. So that means the manager believes H0. So I would write the manager's claim here. And this will help in the last step when I get there, okay? So I'm just going to put a note there that the manager's claim is H0. All right, okay. Apologies for that, my handwriting. I hope you can understand that though. All right, so what we're going to do is for the next step is we need to find what we call the rejection region and the acceptance region. Now, all that basically is, it's areas of a curve that tells you whether to reject H0 or accept H0. Right, so let's, that question is great. No worries, Marty. Marty, I'm saying it right? I hope so. Hope I'm not butchering your name anymore. I apologize for that. Is it Marty, right? Okay. No worries. Okay, so I'm gonna just get back to it. See, you've also got, yeah, yeah. I apologize for that. I have a bit of a chesty one, so please bear with me. Um, okay, so I'll just try and do a quick recap here. We're on the second last learning unit, hypothesis testing, and I'm illustrating it via an example. And this is a typical example that you can get in the exam. All right, you get a question to test a claim, and in this case, you're testing whether the shoppers at a mall spend on average 85 minutes shopping. Right, so that's the claim. What we do is the question tells us that we take a sample of 132 people and we measure what their average shopping time is. And in this case, we find that their average shopping time was 80.5 minutes, right, according to the question. And then we're going to test the theory that the manager stated. His or her theory is that the shopping average of people is 85 minutes. Right? So we declare it as H0 and H1, with mu equal 85 being H0 and H1 equals mu not equal to 85. All right. All right, now we're on the last step. Let's conduct the hypothesis test. So like I said, we need to draw the acceptance and rejection region. Now I draw it personally, but you can get away without drawing it. But either way, you still need to state what the region is. So when I draw it, and then I'll explain a bit more about that, right? So what I'll do is, remember what we said, right? In the second step, we're dealing with the z-stat. So that means we're dealing with the normal distribution, right? The z statistic. So there's our z-axis, right? So if we draw that curve, which is centered at 0, and try my best to draw it here. Okay, there we go, centered at 0. All right. Now this is where this 5% level of significance comes in. All right. Because we are dealing with an equals to and a not equals to for H0 and H1, this is known as a two-tailed test. All right, and I'll explain that in a second. This is known as a two-tailed test, and I encourage you to write this when you are stating your hypothesis, right? Because you get marked for this. Now, what you need to remember for a two-tailed test is if ever you have this sign in your H0, then it's a two-tailed test. Otherwise, it's a one-tailed test. And I'll come to that in the next example, right? But all you need to remember right now is if you see this sign in your H0, it means it's a two-tailed test. All right. So what's so special about a two-tailed test? Well, what happens with the two-tailed test means there's two rejection regions. There's one on the far left here, and then there's one on the far right. And I'm going to shade that in a different color, maybe red. So here's your rejection region on the lower tail, and here's the rejection region on the upper tail. So there's two rejection regions. And the size of that rejection region, that means that area shaded in red, is basically, excuse me, is basically derived from your level of significance from this. What you do is you take that 5% and you split it in half. So you divide it by 2, so half of it goes here, which is 2.5%, 2.5%, and then the other half goes in the upper part, 2.5%. All right, so there's your rejection regions. Now, the tricky part here is you know the areas now because I shaded it and I wrote it out as the values, which is 2.5%. The tricky part now is to find what z value here on this axis corresponds to that boundary. What is the z value? And what you're doing here is as we did in the previous learning units, you're going to work in the opposite way. Before, we were given what the question mark is, and we had to find this area. That's what we had to do. Okay, but now you're given the area, and you're going to find what the question mark is. You're going to find the z value. And that's pretty simple because this blue area is simply just 0.5, remember half the area is 50%, so it's 0.5 take away this red area to 2.5%, so it's 0.025, and that works out to be 0.475, I believe, 0.475. So that's the blue area. So all you need to do is to go into your normal tables. Now you look at where the area, so the value inside the table, where you find the area to be 0.475, you trace back what the Z value is. And if you do that, you'll find the Z value here is 1.96. Now you only need to do it for this one side, right? I'll explain in a second, even though you need to provide the value for the lower tail as well. So the value on the right is 1.96 this here. The value on the left is exactly the same thing, but it's the negative of it because of symmetry. So this is negative 1.96. So you only need to find one, and the other one is just the negative of it. 1.96. Now that you have these boundaries, okay, these boundaries are very important because they're basically your thresholds. They tell you what the region of rejection and acceptance is. So everything on the left, so this where the red area is, if you get any Z value that falls in this region to the left, we reject H naught. So I'm just going to write R there for reject, and it's the same for the right. Anything on the right of this where the area is red, we're going to reject H naught, but anything in between, anything from here to here, we accept H naught. So I'm going to write that in a different color. I'll write it here. We're going to accept H naught here. We accept H naught. Okay, otherwise we reject H naught. The acceptance and the rejection is only regarding H naught. Okay, so remember that. It has nothing to do with H1. It has nothing to do with H1. It only tells you whether you must accept H naught or reject H naught. All right. So now that you found your rejection regions, right, the next step is to determine whether we do accept H naught or reject H naught. In other words, do we accept the manager's claim or do we reject the manager's claim? And that's the next step. All right. So the next step is basically using what you found in your sample to make that decision. All right. Now, what you do is you look at all the information that's given from your sample. You're given the average of the sample. You're also given the standard deviation. If you look at it, the question says your standard deviation of the population is 25 minutes. So sigma is 25, and your sample size is 132. Right? So from your formula sheet, and you don't need to memorize this, we know that Z, I'm going to write this in the block here. To get your Z stat, you use this formula, which relates it to X bar. It's Z equals to X bar, and we did this in the previous learning unit. X bar minus mu all over sigma over square root n. All right? And that's how you work out your Z stat. This is your Z stat formula. And all you do is you plug all those values into the equation. X bar, you plug it in, you plug in your sigma, you plug in your n, all into this equation. The value you use for mu, right? The value that you're going to use for mu is what's in your hypothesis, your first step, because that's what they're claiming. So you use 85 for mu. If you plug all these values into the equation, you'll get a value of minus 2.068. All right, you get this value. And this is the value you're going to compare to these regions. So you're going to see where it falls in this region, and that's going to tell you whether to accept or reject H naught. Now, minus 2.068, if you look at this region here, you got to check where it falls. Minus 2.068 is less than minus 1.96. So it's over here, it's on this side. So that means it does fall in the rejection region. And because it falls in the rejection region, we reject H naught. Reject H naught. All right. So that means my pen stopped writing. Yeah, we reject H naught. Okay, because it falls in the rejection region. Because minus 2.068 is here. All right, it's on the left of minus 1.96. Now, if we're rejecting H naught, which is this, we are rejecting H naught. We are rejecting the manager's claim. That's what we're saying. We're saying that the manager's claim of the average being 85 minutes is not true. That's pretty much what we're saying. But you want to write it in words and statistically. All right, so this is what you would write when you conclude this problem. And this is the last step of this problem. It's just basically writing out your conclusion. All right, so I'm going to make some space on this board and write out the conclusion so you have an idea of how to finish off this problem. All right, a second. All right, so let's get to the text. Okay, so what you would write, the first thing you want to start off with is you want to start off with stating the level of significance. So what you would say is at whatever the level of significance is for this problem, and in this problem it's 5%. So you would say at a 5% level of, I have no idea why this thing is doing that, 5% level of significance, right? The data or the sample, the data suggests that the manager's claim is false. And you can stop there if you want, or you can elaborate and say the average spending time is not equal to 85 minutes. This is how you would finish off the problem. Okay. Yeah, I'll pause there. There's some takeaways on this, right? One of the ways this, remember, in practice, if you ever do use statistics in the real world, right, and in business, etc., these are not just numbers. These numbers tell a story, and you use them to make a decision. So, for instance, you want to sense check your answers to see whether they kind of intuitively make sense. Now, remember, you took a sample, right, and you found the average according to the question. You found the average to be 80.5 minutes. You found your X bar to be 80.5 minutes. Now that's, I mean, just gauging this to that, comparing these two, you can see there is a difference. Now, if someone claimed that the average was 85 minutes, you would expect that if you took a sample, and a sample much bigger than 30, doesn't matter what sample you took, right? If you took this sample or this sample, whichever one, you would expect that the average for any of these samples to be closer to the true value, if that's what they claim. But you can see that 80.5 is actually, it's almost 5 minutes quicker. So that is a difference, all right? And so when you're doing this test, you can kind of intuitively expect there to be a rejection to this claim, because what you found from the sample is different. But you justified it by doing all of this analysis here. All of this work was to prove that. And the reason why you state a level of significance in your conclusion is because if this number, if this 5% was different, say it was 10%, it could change the outcome. All right, so that's why it's very important that you state the level of significance. If it was 10%, you could actually find that you're accepting the manager's claim as opposed to rejecting it, which is why you must mention that in your conclusion. All right, and yeah, so like I said, it's important you critically look at your analysis and the results you get and just try to see whether it makes sense. It's a nice way for you to sense check your answers. I mean, if you have time in the exam, and I know you press for time in the exam to try and finish all the questions you can in the designated time. But if you do have time, it's a nice way to go back, look at your workings and check whether it makes sense. All right. Speaking of the exam, yeah, go for it. When we have our Oh, I'm not sure. I'm gonna have to wait for a heads up from the lead OT. As soon as she gives me a date, um, I will let you know. But no date is confirmed as yet. No worries. Um, any questions? Did people's jaw drop for this section so far? Oh, everyone's okay. All right. Thanks, Caroline. So yeah, like I said, this one question that I showed you can easily carry about 10 marks. So it's very important that you understand all the steps um, for it. Okay, so that's dealing with averages, and now I'm going to move on to proportions, because you can also get proportions. Um, and here's a question in terms of proportions. Let's get back to the question. There you go, what to expect in exam. Yes, exactly. Absolutely. All right, so let's look at this problem. Okay, so I am going to quiz you on this one a bit. All right, so let's read this text. Churn is a term used to describe the rate at which a company loses customers to its competition. In the telecommunication industry, it is believed that the churn rate between cell phone service providers, is the examples, is not more than 15%. So I'm going to highlight this part here, okay, because we're going to use it. Is not more than 15%. All right. Okay. A telecommunications analyst surveyed a random sample of 560. So we'll highlight that part there too, because we're going to use that number. With a random sample of 560. So that's your sample size. And found that 96 of them had changed service providers. So basically 96 out of 560 was the churn rate for that sample. All right. Let's look at the first and only question. All right. It says, is there sufficient statistical evidence at a 10% level of significance? So I'll highlight that part there too. There's your level of significance. To conclude that the churn rate in the telecommunications industry exceeds 15%. All right. So perform a hypothesis test for a single proportion and report the findings. Now remember, in the previous example, we were talking about averages. So here's your population and there's your sample. Before we were talking about averages, but now it's proportions. So the population proportion is pi, right? And the statistic from the sample that we use to kind of infer about the true population is p. This is the sample statistic. All right. So for your H naught, it's not going to be mu, it's not going to be averages, it's going to be pi. Right? So you're going to have H naught and you're going to have H1. H naught and H1. Now, if you had remembered what I said in the previous question, H naught can take only these values. It can take on equals to, less than equals to, and greater than equal to. These are the three values it can, or symbols it can only take, right? So we're going to be talking about pi and pi here, right? So we're going to have to use the symbols for H0 and H1, right? Now this is where this tricky part here comes in. They're claiming that it's not more than 15%, not more than 15%, right? Not more than 15%. Which of these three symbols, 1, 2, or 3, represents not more than 15%? Can you write that in the chat? Basically, tell me whether it's 1, tell me whether it's 2 or 3. That's your multiple choice right now. Which symbol represents this here? Is not more than 15%. Can you put that in the chat, please? Whether what option do you choose? Option 1, 2, or 3? Okay, I've got 2 takers. Very good. Well done. Very good. It is option 2. Yes. So that's what you use for H naught. You are correct. You use this. Less than equal to 15%. You can write 0.15 or 15%. Whether you want to write it as a decimal or percent, I'll leave it up to you. But both are correct. Now, if that is H naught, now remember, H1 is simply the opposite. So if you have that for 2, then you must have the opposite there. If you had chosen 3, then this would have been the symbol, and if you had chosen 1, then this is the symbol for H1, right? It's just the opposite. So in other words, this would take on the opposite, which is greater than 0.15. And like I said, it's good practice to write where the claim falls. So if you read the text, it says, it is believed that the churn rate between cell phone service providers is not more than 15%. So that's where the belief, the claim is. So telecoms, I'll write your telecoms. Double M. I'm just lazy, so I'm writing telecoms. Industry claim. This is what they claim. Okay. All right. So now remember what I told you before is when you have equals to, it's a two-tailed test. And when you don't have that, then it's a one-tailed test. And that's what we have here. This is a one-tailed test. It's a one-tailed test. All right, one-tailed. But you also need to specify, is it an upper test or lower? Now, for me personally, how I identify it is I use the symbol for H1. Now, in this example, the symbol for H1 or the inequality that you have is, a second, there we go. The symbol for H1 is this here. I think of it as an arrowhead that points to where the rejection region is. So if it's an upper tail test, you expect the rejection region to be on the upper side, which is right. Okay, this is upper. If it's lower, then it would be on the left here. Okay, so this sign for H1, I treat it as an arrow pointing to where the rejection region is. So for me, it's pointing to the right, so that means this is the rejection region. I'm going to remove this part here. Right? That's why it's a one-tailed test. If by some chance in another problem you had this symbol for H1, then I see it as an arrow pointing to the left, so that means the rejection region is on the left. Okay, if you had less than. Okay, so it's up to you how you want to remember it, but the important thing is that you do remember and figure out how to find which side the rejection region is, right? So for our example, this is the diagram that you're going to use with the rejection region on the right. Okay, so let me erase the bottom. Here. All right, and for proportions, as in pi, you don't have to worry about deciding whether it's a t test or a z test, or in other words, a t statistic or z statistic. For proportions in this course, you'll only be dealing with a normal distribution, that is a z test. It'll always be a z test, right, for proportions. So you'll have your z-axis here and your rejection region. Now remember I told you it's a one-tailed test, but remember to say that it's an upper tail. okay, because the rejection region is on the right. Okay, so now what is the size of this area? And that's given by your level of significance, 10% here, which I've underlined, is 10%. Now, because there's only one rejection region, the entire level of significance goes here. Or in other words, your level of significance, a symbol for level of significance is alpha. Right? So the entire alpha goes here, and now alpha in this case is 10%. Looks like 16, but it's actually 10. Right? The alpha is 10%. There we go. All right. That's the blue region or the rejection region. So we need to find what is the Z value here. This is the critical value. What Z value corresponds to a region of 10% on the right? So you would go to your table and you would find the area that corresponds with this remaining area on the right. And this remaining area is easy to figure out. Remember, half the area is 0.5, and you've already got 10% on the upper side. So that means the remaining area is 0.5 minus 10%, which is 40%, so 0.4. So you need to find the Z value that corresponds with an area of 0.4. And if you go to your table, you'd find that that value is 1.283. 1.283. So just like before, remember the rejection region is on the right. So anything higher than 1.283, we reject H naught. And anything on the left of it, we accept H naught. I'll put that in a different color. Green. So anything less than 1.283, we accept H naught. All right, and then let's continue with the next step. The next step is to actually work out the Z statistic and then conclude whether you're gonna accept or reject H naught. So let me get back to my blue color. All right, so the next step is calculate the Z statistic. So the Z statistic for proportions in your formula sheet is this. Now you need to relate Z to pi. And if you look at your formula sheet, you have this formula. Z equals to P minus pi all over square root pi into 1 minus pi all over n. All right, and you have all the values you need to plug into this equation. All right, I'll explain that to you now. Pi is what you have, what you're going to use for pi. For pi, you're going to use what you have in your hypothesis. So in other words, 0.15. Whatever you state in your hypothesis, that's what you're going to use in here. All right. For P, that's what you got from your sample. Now, if you look at your sample, remember we're trying to measure churn rate. So your sample is 560 people, and out of those 560, 96 of them changed service providers. So the proportion in your sample is P, which is given by 96 out of 560. So that's your P that you're going to use in this equation. So you have P, you have pi. The last symbol you need is N, and that is simply your sample size. How many people are in your sample? It's 560 people. Okay, so your sample size is 560. So if you plug all those values into the equation, right? If you do that, you'll get a value of, I'll tell you now, 1.42. Okay. You get a value of 1.42. Okay. All right. So this is your statistic. Now I'm going to ask you this question. You got this statistic for this step. The next step is to compare it to where it falls here and decide whether to accept or reject your H naught. So can you tell me in the chat, based on this value that you found here and what your rejection region cutoff is, do you accept H naught? So can you write whether you accept H naught? You can just write accept if you want, or do you reject H naught? That's my question to you. Accept or reject? Thumbs up or thumbs down? Thumbs up for accept, thumbs down for reject. We're at the last step now. Okay, someone's giving it a shot. Great. Anyone else? Let's see. Very good. Very good. You reject it. Yes, because you can see 1.4. Okay, 1.4 is bigger than 1.28. So that means it's on the right of it. It would be here. It's not less than that. So it falls in the rejection region. Exactly. So we reject H naught. That's it. Very good. So that means if we're rejecting H naught, and H naught is where the telecoms industry claim is, we're actually rejecting the industry's claim. So we would write this in words in the final step. If I can get this cursor to work. Okay, so remember we reject H naught, so I'm just going to make some space here. All right. And this is how you conclude this question. Remember what I said? You always finish starting with, sorry, you always start the sentence by saying the level of significance, okay? So in our case, it's 10%. So you would say at a 10% level of significance, right? The data suggests the, you can, yeah, let's put the forward, telecom communications industry claim is false because we're rejecting H naught. All right, the 10% level of significance, the data suggests telecommunications industry's claims, yeah, is false. This, excuse my grammar, but essentially that's pretty much it. You can elaborate and say, if you're rejecting this, remember if you are rejecting this, so I'll put a, if you are rejecting this, then what you're saying is that the proportion of churning, or sorry, proportion of churning, the churn rate is actually greater than 0.15. That's what you're saying. You're rejecting H naught. That means you believe that the churn rate is greater than 0.15. All right. That's it for hypothesis testing that I wanted to cover. As an exercise, I am going to give you a t-test to do. Yeah, just I'll make an announcement for that. But I highly encourage you to work through it, and I'll give you the workings for it to compare your answer to it, right? To check whether you understand it. Has anyone done any of the practice tests by any chance? I just want to get an idea if anyone has made use of it and how did they feel it. Okay, no worries, but it's there, and great. I have made the what do you call it? The test available to after the exam. So I mean, I don't expect anyone to be working with it after the exam. So you can work with it whenever you get a gap. But that's it from me today, this evening. Are there any questions? Is anything unclear? And then if not, next week I'll cover the last learning unit, which is chi-square tests. Yeah, please work through the tests. it is useful. It will help you in your studying. All right, everyone. Thanks for joining, and that's it from me. I will chat to you soon, and have a great week.